this is part 2 of chapter 1. We are asked to add these numbers together. 3.4 plus 0.07 plus 6. Okay? Yes, you can use your calculator, but I do want to remind you how adding decimals work. When you do this, you need to make sure that you're lining up your decimal point. So this is 3.4 plus 0.07 plus 6. Okay, the 6 has an understood decimal point here. I can add zeros here and here so that these match up, and I can add a 0 here as well. Now add as usual. 0 plus 7 plus 0 is 7. 4 plus 0 plus 0 is 4. Your decimal place is in the same spot. And then 3 plus 0 plus 6 is 9. So your answer is 9.47. 3.4 plus 0.07 plus 6 is 9.47. So it is correct. Okay. So let's look at example 10, same chapter. This is a subtraction, and yes, you may use your calculator, but you also need to line up your decimal point when you're adding or subtracting. So this is 5 minus 0.45. Now, adding the zeros when you are adding is a convenience. When you are subtracting, it really is necessary. Okay? Now, if we do the subtraction, we need to remember how to do the borrowing and everything if we're doing it by hand. I cannot do 0 minus 5, so I borrow a 1 from 50 to give me 49. Technically 4.9, but you get to the decimal point is just lined up, so you don't have to worry about that so much. 10 minus 5 is 5. 9 minus 4 is 5. 4 minus 0 is 4. So your answer is 4.55, which of course you can also get using your calculator. 5 minus 0.45, 4.55. Okay, so example 11, let's multiply decimals. Again, I'm going to remind you how it works without a calculator, and then we can talk about using a calculator for it. Okay, with multiplication and also with division, you do not need to line up your decimal point. Basically, at first, you treat it like a regular multiplication problem and ignore the decimals. Okay, so let's multiply these. 6 times 2 is 12, carry the 1. 6 times 4 is 24, add 1, that's a 5, carry the 2. 24, yeah, that's 5. All right, 6 times 0 is 0, plus 2 is 2. 6 times 3 is 18. We move over a place. You can add in that 0 right there if you want to. And now multiply by 1. 1 times 2 is 2. 1 times 4 is 4. 1 times 0 is 0. 1 times 3 is 3. Now we add these together. Technically, you could do another line and multiply everything by 0, but that's a waste of space and thought and time. Okay, so now let's add. That's a 2, 7, 6, 8, and a 4. Okay, now we just need to figure out how many decimal places we have. What you do is you look at your original problem and you count how many things you had after the decimal place total. Here I have 1, here I have 2. So 1, 2, 3. I had 3 decimals in the multiplication problem, so I have 3 decimals here. This is 48.672. And of course, your calculator will do this as well, and more quickly. Okay, Now, the reason I'm showing you how to do this without is it will give you a better understanding of what kind of answers are possible, what you should expect to have, so that if you accidentally enter something on a calculator wrong, you have a better chance of saying, that can't be right, I better do that again. But of course, since your math is going to be dealing with human lives, you probably want to do all your calculations twice anyway. Okay. 304.25 times 10. Now, just like when we were dealing with the fractions and we were dividing by 10 or 100 or 1,000 and it was moving decimal places, multiplying by 10 or 100 or 1,000 is also going to move decimal places. When we were dividing, we were making things smaller, so we're moving our decimal place to the left. When you're multiplying, you're making things bigger, so you move your decimal place to the right. And the zero, how many zeros you have, also tells you how many decimal places to move it. So since this is times 10 and it has 1 0, I'm going to move this over to here. So this is 3042.5. And of course, you may use your calculator and you should get exactly the same answer. Okay, if I have this problem, again, I'm multiplying by 1,000, so I'm going to be moving my decimal 3 places because it has 3 zeros, which is 1, 2, 3. So basically, I lose all of my decimals here. This is now 23,597. Okay, so we want to write this fraction, 106.8 divided by 15, as a decimal number, rounded off, so that's regular decimal place, to the nearest tenth, which is 1 decimal place. Okay, first thing I'm going to do is I'm going to do this division. I get 7.12. Okay, now we're supposed to round this off to the nearest tenth. This is our exact answer. Here's our tenths spot. We're asked to round off, so I look at the 2. The 2 is less than 4, so this is going to stay the same. This is approximately equal to 7.1. I should have introduced this symbol before. The little squiggly equal sign means that we have rounded. It is an approximation. Okay. All right, so let's look at example 15. All we're being asked to do is simplify. This is a division, so we do 48 divided by 0.002, and that equals 24,000. Okay, so let's look at example 16. Which is larger, 0.4 or 0.23? If you are not careful, you'll look at this and say, well, that has 2 digits, this one has 3, so this one's definitely larger. And of course, that works perfectly well when you're dealing with numbers that are not decimals. If it helps you, go ahead and rewrite them so you have a matching number of decimal places. So I could do 0.4, which is the same thing as 0.40. Okay? And then you'd look at it and say, well, 40 is larger than 23, so this one's larger. That's one way of doing it. The other way of doing it is to compare from the left to the right, each decimal, okay? So each of these has a 0 in front, so that doesn't tell me. I move over to the next digit. A 4 or a 2, 4 is larger than 2, so this is the larger number. I'm done. Okay, if this is also a 2, then I'd go to the next one, and then I'd go to the next one, and so on. So this is the larger number. Okay, so is 0.5 divided by 0.4 smaller or larger than 1? Of course, you could use your calculator and find the exact answer, but you don't need to. okay? A fraction is always going to be larger than 1 if your numerator is larger than your denominator, okay? It is going to be smaller than 1 if the top is smaller than the bottom, okay? So basically, if this is saying if we have a proper fraction where the top is smaller than the bottom, and this is going to be an improper fraction, okay? So basically our question is 0.5 larger than 0.4 or not? Our zeros are the same, move over. 5 is larger than 4, so the top is larger than the bottom. So that means it is an improper fraction, which is larger than 1.